Yes, it's a good day from morning till
night. Web navigators, hello and welcome to PC Tips Tricks. Why force the PCIe generation? Forcing the activation is a measure for both stability and performance. First, I will perform a comparative graphical benchmark using this software. The auto trap leaving the BIOS on auto forces the motherboard to perform link training at every boot. Link training is an automatic process where the motherboard and the graphics card talk to each other to determine the maximum speed and stability of their connection. The PCIe controller sends test signals, texture files, etc. through the PCIe port. It checks if the data arrives without errors at the other end and responds correctly within the selected gen. What is gen? When we talk about the generation, we are talking about the hardware's ability to process information faster or slower. Forcing the appropriate generation ensures that the language spoken is as fast as possible, without ever degrading signal quality. Startup stability. By forcing the setting, this phase of uncertainty is eliminated, preventing interference. In a PC case with dozens of fan and RGB cables, electromagnetic interference (EMI) can disrupt PCIe lines. Forcing a higher gen ensures that the motherboard maintains a constant signal voltage rather than erroneously attempting to downshift to a lower gen. In auto mode, the motherboard may hesitate regarding signal quality and mistakenly switch to a lower gen to secure the connection. Saturated bandwidth. The RTX 3090 was one of the first graphics cards to truly saturate PCIe 3.0. Evolution of speed, bandwidth. Each new generation doubles the speed of the previous one. For a PCIe 16 port, Gen 3 9 GB per lane, approx 16 GB total, Gen 4, 2 GB per lane, approx 32 GB total, Gen 5, 4 GB per lane, approx 64 GB total. Manual forcing locks the communication. The importance of the X16 link data throughput. X16 represents the number of lanes. By moving from X4 to X16, you quadruple the amount of data the processor can send to the graphics card simultaneously. Don't forget your NVMe SSDs. If you have a Gen 4 NVMe SSD, leaving it on auto in the BIOS puts you at risk of seeing your transfer speeds cut in half without even knowing it. Some SSDs promise high speeds, but in auto mode, if the BIOS detects significant heat or slight instability, it may throttle the slot to a lower gen. You would lose half the performance you paid a premium for. Direct storage smoothness. Forcing the higher gen locks in the maximum throughput. With the arrival of direct storage in recent games, data passes directly from the SSD to the graphics card. If the SSD is forced to the higher gen, the transfer is smoother and faster. Reducing micro-stuttering during on-the-fly texture loading. The critical case of lane sharing. On high-end motherboards, some PCIe ports and M2 slots share the same bandwidth. By manually forcing each slot, GPU and SSD, to its highest gen, you impose a clear hierarchy on the BIOS. This prevents the system from randomly sacrificing SSD speed to favor another component during startup. Heat management. Gen 4 NVMe SSDs can sometimes run very hot. The SSD controller and the BIOS communicate to lower the generation to reduce heat. Force the corresponding higher gen in the BIOS only if you have good cooling and a heatsink. This maintains constant performance even when transferring hundreds of gigabytes. Forcing the proper gen on your M2 ports ensures your games and OS load at lightning speed without any software bottlenecks. Activating resizable bar. This is the final optimization for your graphics card. Traditionally, the processor can only access small portions of video memory, VRAM, at a time. With resizable bar, the CPU has direct and total access to all the GBs of your card's VRAM. The gain is real. It reduces bottlenecks and can improve FPS by 5% to 15% in certain games while making the frame delivery smoother. BIOS walkthrough. Never leave the configuration on auto though. Force the port to the highest gen supported by your motherboard. This guarantees signal stability and prevents crashes or boot failures. Here are the results of the graphical benchmark. They are more than decent compared to online results. I'll open GPU-Z to show the current info. Resizable bar is disabled. Here you can see if you are running at the correct Gen SSD benchmark. Let's move to the NVMe speed benchmark. Information in Crystal Disk Mark often flatters the ego with impressive numbers like 6000 maybe S+. But the 4KB Q8T8 line represents the true responsiveness of your daily system. 4KB corresponds to the standard 4KB size of the vast majority of data read by Windows and games, system files, textures, logs, etc. Q8 QDepth simulates 8 pending read-write requests. T8 Threads simulates 8 processes working on this data simultaneously. Unlike large 50 GB files that use sequential reading, your system spends 90% of its time handling thousands of tiny scattered files. The higher the 4KB value, the snappier Windows feels and the faster applications open. I'll use the shortcut I created to access the BIOS-UEFI. See video NDG 545. Otherwise, restart your PC and repeatedly press the Delete-Del key. Go to the Advanced tab. Select Onboard Devices Configuration. In some BIOS versions, it might be located elsewhere. Scroll to the bottom. Find PCIe X16 mode, currently on Auto. Click the arrow and choose the higher gen, AGE, Gen 4 or Gen 5. While you're here, find Resizable Bar and set it to On. Press F10 to save and exit. Click OK to reboot. Final comparison. After rebooting, graphics gain 24% performance increase. GPU usage check. Resizable bar is enabled. PCIe is at X164. So, note, if it shows 1.1, it's just in power saving mode. SSD gain. In this example, an increase of 69 Mbps in read and 101. 3 Mbps in write, over 5% improvement. In computing, a 5% plus jump in random write, 4 KB, means much better system reactivity during heavy workloads. You now have the tools to significantly improve your PC. It's your turn now. I hope you enjoyed this video. See you soon in the next video.